Hello everyone. I hope everyone is doing well. And now today we will start our chapter 3 revision. The chapter 3 title is Forces and Movement, as you can see. So this chapter included these topics like we know unbalanced force. Unbalanced force is equal to mass times acceleration. Unbalanced force is equal to mass times acceleration. So whenever we write F equals to ma, it doesn't mean any random force equals to ma. What actually means ma? Mass into acceleration is actually equal to the unbalanced force, like the thing we revised in the last class. Suppose two forces are acting on an object, okay? So two forces are acting on an object, like towards right there is 500 Newton force and towards left there is 200 Newton force, okay? And the object that is being pulled, or the forces are acting on the object, the mass of the object is suppose 5 kg, okay? So now what will be the F? What will be the value of F for this situation? Like an object of 5 kg is being pulled towards the right with 500 Newton force and being pulled towards the left with 200 Newton force. So what will be the value of F? The value of F will be the unbalanced force. What do we mean by unbalanced force? We can clearly see, or we always know, that 500 is larger than 200. So the unbalanced force is equal to 500 Newton minus 200 Newton, which will give us 300 Newton. So the value of the unbalanced force is 300. So the value of the unbalanced force is 300. So we will write F equals to ma. So if we want to calculate the acceleration, okay, if we want to calculate the acceleration is equal to F by m. Now which will be the value of F? 500, 200 or 300? Which will be the value of F? This 500 Newton or this 200 Newton or this 300 Newton? It will be the 300 Newton, because the F equals to ma, the formula F equals to ma actually implies the F is the unbalanced force, okay? So the unbalanced force value is 300 Newton and the mass of the object is 5 kg. So this will give us 60 meter per second square. The unit of acceleration is meter per second square. So this is the actual idea about unbalanced force equals to mass into acceleration. Now for this relationship we had some graphs. I hope you people remember, like F equals to ma. For this we said if mass is constant, wait, let's make three separate columns and do those. We are making 3 separate columns, okay? So for the 3 columns we will have 3 different constant values. All right, so for the first column F equals to ma, we will keep the mass to be constant. All right, we will keep the mass constant. So if acceleration increases, the force increases. So the force is directly proportional to acceleration. This is what we write. So the graph, okay, the graph of acceleration versus force, or force versus acceleration, you can draw any one of them. It will give us a straight line through the origin. In the Hooke's law chapter we already learned that for two variables to be directly proportional with one another, their graph must be a straight line and it must pass through the origin. So this was the condition 1, or the column 1. Now for the second column, F equals ma, okay? Now if we keep the force constant, if we keep the value of force to be a constant, first of all let's make acceleration the subject of the equation. Acceleration is equal to unbalanced force by mass. So acceleration is equal to F times 1 by mass. Now if F remains constant, okay, if F remains constant, let's write F is constant. So if F remains constant, we can clearly see that the mass is on the denominator. Okay, the mass is on the denominator, so as the mass increases, the value of acceleration must decrease. So they are inversely proportional with one another. Okay, so if one variable increases and causes the another variable to decrease, then this sort of relationship is called inverse relationship or indirect relationship. Okay, so the graph, we had two graphs for this situation. First, for acceleration versus mass graph. Okay, for acceleration versus mass graph, the shape of the graph was like this, and for acceleration versus 1 by mass graph, okay, for acceleration versus 1 by mass graph, the graph gave a straight line passing through the origin. All right, now for the third column and final column, we have, again, let's write down the equation F equals ma. Now let's make mass the subject of the equation. All right, let's make mass the subject of the equation. So, or let's keep it that way, F equals ma. Now in this case, if acceleration remains constant, which means that the objects will be of different masses. Okay, the objects will be of different masses, but I want them to accelerate at the same rate. So a heavier object will require a larger force and a lighter object will require a smaller amount of force. So as mass increases, the amount of required force, okay, the force that will be required to accelerate the object will also be greater. So in that case, force is again directly proportional to acceleration. Okay, we already explained why, because the heavier the object is, the greater the force will be required to accelerate the object at the same rate. All right, so the force versus mass graph will be like this. The force versus mass graph will give a straight line passing through the origin. So these are the graphs that we should know. Okay, this will come in our daily test exams as well, and these are the things that always appear in school exams, and these sort of things are required for our basics to be clear from the right go. Then what we have in this chapter is thinking distance, braking distance, and stopping distance. We already studied these chapters, and we have clear idea what we are actually revising. Okay, so thinking time, braking time, and stopping time, and thinking distance, braking distance, and stopping distance. In this video, I will not write all the definitions and all the factors. You must revise the notes. Okay, revise from class lectures. All right, because it will just make the video more lengthier if I just keep on writing all the definitions and all the factors. All right, so when watching this video, bring up your class lectures and match up with what I am saying and try to understand or try to revise. Okay, so first of all, the thinking time. What is this thinking time? This thinking time is the time taken by the driver when he sees an obstacle, right? Like a driver is driving a car or vehicle and he sees an obstacle in front of him. Now it will take a certain amount of time for him to react, like if he must apply the brakes or not. Okay, so the time taken for him to think, that is from seeing the obstacle up to applying the brakes, the time that will be taken will be thinking time. Okay, and the distance that will be covered during this time is called the thinking distance. It's that simple. Then braking time. Now just after you apply the brakes, the car doesn't come to rest, right? It keeps on moving even after you applied the brakes, because it already has a greater value of velocity. So the time taken for the car to come to a complete rest from what, like after the brakes have been applied up to the point the car comes to rest, it is the time called braking time, and the distance that is covered during this braking time is called the braking distance. All right, so the total time taken for the driver to think and the car to stop after applying the brakes, the total time, thinking time plus braking time, this will give us the stopping time, and the total distance that will be covered will be stopping distance. So that was the thing that we actually had to study. And the factors we already discussed, like the factors for thinking time. What are the factors that will affect the thinking time of a driver? Like if he consumed any alcohol or not, if he is being able to see clearly, like the visibility of the driver. Okay, then the mental tiredness of the driver. So these will be the factors that affect the thinking time. Then the braking time, it depends on the brake condition, tire condition, weather condition. All right, mass of the car, velocity of the car. So a lot of factors affect the braking time, and the factors that affect thinking time and braking time as a whole will affect the stopping time. Okay, so revise the class lectures, and I want all of you to score full marks on the daily tests and the MCQ tests. So this will be the first half of the revision of chapter 3. In the next class we will study about terminal velocity. So that's it for today.